Okay, so we're working on the power rule and the slope of the function, the derivative. And so if I'm given g of x is here, I'm looking for the derivative of g of x. So in order to help me find the derivative, I'm going to take my function and I'm going to expand it out. And so when I expand it out, I get x squared minus 1 plus 2 is plus x minus 2, which gives me half x squared plus half x minus 2. So when I now take my derivative, which is what the question is asking me for, the 2 comes down, 2 times a half is 1. So I get x plus 1/2, because the 1 comes down and comes to 0, and the negative 2 goes away. So here is my derivative. B part says find the gradient of the curve at the point where x equals 2. Well, that just means I'm going to find the derivative at 2. So I get 2 plus 1.5, or 1/2, which will be 2.5. I can check that in my calculator. One of the things I can do, I've already graphed g of x. So if I go second trace, and if I do number 6, which is the derivative, and if I ask it for the derivative at 2, I can see the derivative is 2.5, which I got. The other way I could do it, if I quit this, if I go to math number 8, I'm going to do the derivative with respect to x. I have y1 in here, and I want to find the derivative at 2. And again, I get 2.5. So there's lots of ways we can find the derivative with our calculator. The next part here, C part, it says using your GDC to sketch the graph and its derivative. Well, I can already see that I have the graph. If I want to sketch the derivative, again, I go to math, and it's number 8, the derivative of x. Well, I want to do it, the derivative of y1, and I want x to be every x that exists. So this is every x. And now when I graph it, I get that line there. And so if I pull this over, let me pull this graph over so we can talk about it. Okay, so here is C part finished. Now, D says write down the set of values for which x is increasing in the video. Well, what we can see here at this point here is when the derivative is 0. That means it is a horizontal tangent line. That is when a function typically could change from increasing to decreasing or decreasing to increasing. And so if I look carefully at my graph, I can see that at this point it starts to increase. Or the derivative, these are all positive values here. Not the slope, but the values, the y values are actually positive, all positive, 6, 7, 8, 9, 10, and so on. And so from this value here upwards is where the derivative is increasing. So I'm going to try and find, I'm going to find the 0 of not y1, but rather y2. And I'm going to go from, I don't know, -2, let's say, to 0. And I'll guess -1. And I can see that when x is bigger than or equal, sorry, just bigger than negative 0.15, I know that g of x is increasing. Okay, I could also have taken this here, set it equal to 0, which will find me my turning point. So then I get x is equal to -1/2. I can analyze the graph and see that this is positive y values, and so increasing when the derivative is positive.